Good evening, everyone. Welcome to another webinar session conducted by Open Education Webinar. As you all know, this is a regular session every weekend, every Saturday evening 4:30. We will be conducting this live webinar. The webinar will be of almost half an hour to 1 hour. Any doubts you have, please put in the messages, and we'll be covering one topics, one simple topics. So today we are going to talk about something very basic but very powerful. Not programming, not machine operation, but something that comes even before that. That is how to read a CNC drawing properly. So I will tell you one honest truth. Most people don't make mistakes in CNC because it is not because they don't know programming. They make mistakes because they didn't understand the drawing correctly. If drawing understanding is wrong, everything that comes after that will also be wrong. So today, I'm going to show you a very simple way, a step-by-step way, so that when you see any drawing, your mind becomes calm, it will not be confused, and by the end of the session, you should feel like, okay, this is not a big headache. This is simple. This is not much to worry about. All those things. So let's start it. Let me first ask you a question honestly. When you guys, I don't know to trick, but I want you to keep this thing in mind. So when you reply or when you see a new drawing, what happens inside your head? I mean, do you feel confused? Do you feel like there are too many numbers, too many lines, and everything looks important? Do you feel like where should I start? And one more important thing, do you feel a little fear? Fear that if I misunderstand this, I will make a mistake on the machine. If you are feeling this, it is completely normal. Every beginner and even many experienced people go through the same issue of yours. So, so the problem is not you. The problem is nobody taught you the simple method to read drawings. Today I will try to give that method. Now, first of all, let's understand why this is so important. Okay, imagine you have written a perfect CNC program. You select the correct tools, you set everything properly, but you misunderstood one dimension in the drawing. What will happen? The final part will be wrong. That means material is wasted, time is wasted, effort is also wasted, and slowly your confidence also goes down. You start thinking, am I doing something wrong? But the real issue there is not your skill, it is the way the drawing was understood. Once your drawing reading becomes clear, everything else will become clear. So what will happen if you A wrong reading, that means that it is a wrong part. It will waste the time which you worked and the material also. It will affect the job quality. Then it will impact your confidence also. Now, today I'm not going to explain or teach or anything, any complicated theory. No heavy words, no confusing explanations. I will show you a very simple method. A method you can follow every time for any drawing. First, how to look at the drawing. Then, how to understand the shape. Then, how to slowly read the dimensions without confusion. And finally, how to think like a machinist. Because a machinist does not just see the drawing, he sees the final part and how to make it. That's the mindset we are going to build today. Because when you become a programmer, before becoming a programmer, you always have to be a operator first. First, you have to think from the operator's point of view. Once you get a look at the operators, once you put your shoes in the operator's shoe, legs in your operator's shoe, you will get to know what are the problems you're going to face. What is the easiest solution for them? All these things will be discussed there. Now, a drawing. When you look at a drawing, first reaction may be sometimes confusion. Why? So many lines, so many numbers, so many arrows, so many symbols, so many what is it? Views, all those things. What is happening? Your brain tries to understand everything at once, and that's where the problem starts. So let me tell you something very simple but important. A drawing is never complicated. We are just the problem where it is we are just trying to understand it in the wrong way. We are trying to see everything at the same time. Instead, we need to slow down. We need to follow a proper order, like reading a story from beginning to the end. From the so from beginning, we have to see all the views, separate views individually, not together. If we start seeing it together, it will be a confusion later. So from the next slides, I will show you that. I will show you this exact order. And once you follow that, I feel the same drawing which once confused you so much will look very simple and very easy to understand. Now, before we start anything, okay, obviously, before we start anything, we have to see two things. Before we understand the shape, there are two small things that you must look for. One is the unit, which will be mostly in millimeter itself. That's why I don't mention here. What is the unit you have to see? Second thing is the projection symbol. So you may be thinking when I say projection symbol, oh, no, that's such a small symbol. Is that really important? Yes, it's extremely important because this small symbol decides how the entire drawing is arranged. If you miss this, your brain may interpret the drawing in the opposite way. So let me explain. Someone gives you directions, but the north and south are swapped. You may walk perfectly, but still you will reach the wrong place. Same thing happens here. If projection is misunderstood, even if you read all the dimensions correctly, your final understanding will be wrong. So from now, just build this habit. Whenever you get a drawing, don't rush. Pause for a moment, scan the sheet, and first find the projection symbol. That 1 second checking can save you hours of mistakes. So what is projection? I told you projection, projection, projection. So it's a very simple thing. Let's not go to the rocket science or anything. No big theories. We are trying to show a real object, which is in 3D on the paper, but on the paper it is in 2D. Now, paper is flat. It cannot show the depth directly. So what do we do? We break the object into views. We'll have different views. What are the views? Front view, top view, side view. So each view shows one face of the same part. Like if I give you a box and ask you to draw it, you will draw how it looks on the front, then how it looks on the top, then how it looks on the side. All these three together gives you a full understanding. So projection is nothing but a method to represent a real 3D object using multiple 2D views. Once you understand this idea, drawings will stop looking like random lines and start looking like different sides of one single object. Now, there are two main ways of arranging these views: the first angle projection and the third angle projection. So, nothing to worry about these names, most of them may be knowing. So, you need not go into deep theory or memorize definitions, just focus on one important. These two methods arrange the views differently on paper. That means in one method, the top view may be below, and in another method, the top view may be on the top. So if you don't know which system is used, you may think you are looking at the top, but actually you are looking at the bottom, and that creates a confusion. So again, I repeat, always check the projection symbol first, then only start reading the drawing. Now, let's understand first angle projection slowly. So here you can see the image itself. The top view comes below the front view, and right view comes in the left side. Okay. So in this method, in the first angle projection, the arrangement is opposite to what we expect. So top view will be placed below the front view. The right side view is placed on the left side. So everything feels a little reversed. At first, this can be confusing. Your brain normally expects top view on the top, but here it is below. So what should you do? Don't try to force yourself to memorize blindly. Instead, understand one simple rule. In first angle projection, views are placed opposite to their actual position. That is it. So whenever you see this projection, your brain will adjust automatically. Also remember, in India, or most of the Asian countries, most of the drawings follow this first angle projection. So this you may be seeing in the real jobs. Next is a third angle projection. So let's look at the third angle projection. This one feels more natural. So here top view is placed above the top view, right view is placed on the right side. So whatever you see matches what your brain expects. That's why beginners usually feel more comfortable with this system. But here is the important part. You cannot assume which projection is used. Never think it looks like third angle, so I will read like that. Always confirm using the symbol. Because even a small assumption here can lead to a completely wrong understanding of the part and can lead to damages. So again, slow down, check the symbol, then proceed. That is how a real professional reads a drawing. Okay, now we have done the first important step. Actually, say two important steps are discussed. First one is the unit, and second one is the symbol. We check the projection symbol, so now we understand how the drawing is arranged. Now, what usually happens is people feel a little confident and immediately jump into numbers. They start reading dimensions randomly, but again, this will create confusion because numbers don't make sense until you understand the shape. So don't rush here. Instead, take another small pause. Look at the drawing again, calmly. Now ask yourself one simple question. Which view is giving the most information? That is what we call the main view. If you start from the correct place, half your confusion is already solved. So always remember, don't jump into numbers. First find the mean. Now what is main view? So main view means the view that shows the maximum information about the part. In most of the cases, it will be the front view. But never blindly assume. Sometimes depending on the drawing and the view may show more details. So your job is simple. Look at the views and identify which one is giving you the clearest picture. Which one shows the shape more clearly. Which one has more features visible. That is your starting point. Like, you can just think it of like this. If someone shows you a person's photo, you first look at the face, not on the hands. Same way in drawing, start with the view that shows the most information. Once you understand the view properly, the rest becomes easy. Now, why are we focusing so much on just one view? Because our brain likes simplicity. If you try understanding everything at once, it becomes messy. But if you start with one clear view, your brain starts building a picture step by step. The main view gives you the overall idea. It tells you what kind of part it is. Is it long? Is it flat? Is it stepped? Once this basic idea is clear, other views will only add extra details. So instead of confusion, you will feel clarity. That's why professionals also start from the main view. They don't try to be fast, they try to be clear. Now, this is where things become interesting. Don't just look at the drawing like a paper. Start imagining the real part. Close your eyes for a second if needed. Try to picture the part in your hand. Is it heavy? Is it round? Does it have steps? Can you rotate it in your mind? At first, this may feel difficult, but slowly, with practice, your brain will start doing this automatically. And once that happens, drawings will no longer feel like drawings, they will feel like real objects. And when that happens, confusion disappears because you are no longer reading lines, you are understanding a real part. Let me tell you something very important here. This is where some beginners go wrong. So they try to read everything at the same time. All views, all dimensions, all details. Naturally, the brain gets overloaded. Then they say drawing is difficult. But the truth is, the drawing is not difficult, the approach is so. Instead, follow a simple order, one step at a time. First projection, then the main view, then visualization. Never hurry. Even if you take it to a few extra minutes, it's okay. Because one correct understanding is better than fast confusion. That's how the professionals think. Now we move into a very powerful idea. Every CNC part, no matter how complex it looks, it is actually made of simple shapes. There is no such thing as a complicated part. It's just a combination of simple things joined together. For example, cylinder, block, step, hole, etc. That's it. But when everything comes together in one drawing, it looks a bit complicated. So what should we do? Don't try to understand the full part at once. Break it down, just like how we eat the food. When you're having a dosa, will we eat it in a mouth? No. We'll piece it into parts, right? Similarly, one bite at a time. So in the drawing, what we'll do? We'll do the one shape at a time. That's the most common shapes you will see again. Cylinder, mostly in turning parts. Block, very common in milling. Steps, where the size changes. Holes, this is the drill or Board features, that's it. Most of the parts you see in the real life are just combination of this. So instead of thinking this drawing is big and complex, start thinking, okay, I see a cylinder here, a step here, a hole here. That's all. Now it becomes more simple. Now here is a trick. Don't try to understand everything at once at all. Just pick one feature, maybe a hole or one step. Focus only on that. Understand it properly. Then move to the next one. Slowly, piece by piece. This will build the full picture in your mind. So this is how experienced people read the drawings. They don't rush. They build understanding step by step. What is a step? It's total step. So when we come in, this step is used mainly in CNC turning. So this is actually a simple feature. A step means change in size. For example, one diameter here, little front, it becomes a smaller diameter, then again a smaller diameter. It's like it's very common in the shafts. So whenever you see a size changing, that is known as a step. And why this is important? Because each step usually means a separate machining operation. So when you identify steps, you are already thinking like a machinist. Huh? You are not getting ready your plan. Even in VMCs also, we have blocks where we read as steps. There are also that stepped characters as a step. Next, what is a hole? Hole is another common feature. Most common feature. Hole is everywhere. There are two types. There are different types actually. We have through hole that goes completely through the part, and we have blind hole that stops at some depth. Now, why this is important? Because machining will change based on these features. Through hole will go, the full drilling will be going. Blind hole will do controlled depth. Maybe, for example, can be dia 8 to 10 mm or 12 mm or 13.5 mm, whatever. That's known as the drilling or holes. So when you identify features like this, you are not just reading, you are already thinking about how to machine it. And that is our main goal also. Now let us slowly shift our focus back to VMC parts. In turning, the most things are wrong, but in VMC, it becomes interesting. You see different types of features. The most common ones, holes, pockets, slots, or the profiles. Almost every VMC component you see will have a combination of this. Now, don't worry about machining right now. Just focus on identifying. When you look at a drawing, your brain should start to question, okay, this is a hole, this is a pocket, this is a... If you misunderstand the type of holes, you may choose the wrong tool, wrong depth, and wrong process, and the part will be rejected. So whenever you see a hole in the drawing, don't just see the circle, ask yourself, is it true or blind? Is it threaded or it does it has any extra feature on the top? This habit will make you very strong in VMC. Right? Now let's talk about pockets. What are pockets? Sorry. Slot is another common feature. It means an open cut. Unlike a pocket which is closed, slot usually connects from one side to another. It can be straight or sometimes curved. You can often see slots used for fitting parts or allowing the... Now, from the drawing point of view, you should identify where the slot starts and where it ends and what its width and depth. Once you see this clearly, you're already thinking in a program level. Now, next is the profile. What's a profile? Profile means the outer shape of the body. This is the final point. After all internal features are done, profile defines how the part looks from outside And here the profile cutting is very important, especially for finishing. If profile is wrong, the whole parts looks wrong. And so when you see a drawing, always take the outside shape carefully. Is it square? Is it rounded? Any curves? Because this is what gives the final identity to the. So again, don't rush, observe properly. Now we are coming to one of the most important concepts in CNC, that is a zero. Or you may also hear the word datum. Don't worry about the word, understand the idea. Zero is simply the starting point. It is a point from where all measurements begin. In a drawing, every dimension is taken from somewhere. That somewhere is a zero point. Now imagine this. If you don't know where zero is, all your dimensions are floating with no reference. So even if your program is correct, the part will be wrong because your starting point is wrong. That's why zero is very, very important. Sorry for the. Now, in VMC or a vertical milling machine, everything depends on coordinates. X, Y, Z, all are based on zero. The machine doesn't understand your drawing directly. It only understands the positions relative to zero. So if your zero setting is wrong, even a perfect program will produce a wrong path. For example, you programmed a hole at x50 y50, but your zero is shifted. That hole will go somewhere else. So always remember, before running your program, first confirm your zero. That is the foundation. Now the question is, where is the zero in the drawing? It will always be mentioned, but not always clearly highlighted. Sometimes it's at a corner, sometimes it's a center, sometimes it's on the surface. Your job is to find it. Look at how dimensions are given. From where are they measured? That point is your zero. And once you find that, everything becomes easier to understand. Now, in the VMC, there are mainly two types of zero. One is the machine zero, and the second is the workpiece zero, or also known as the work offs. Machine zero, it's always fixed. Machine zero will be always fixed, and workpiece zero will be changing as per the work. It is what we set based on the drawing. This is the zero we use for programming and machine. So when we talk about drawing, we are mainly talking about workpiece zero. That is what connects drawing to the machine. Let's make this very simple. Think of a zero like your starting position, like standing at the entrance of the room. From there, you take the steps 10 steps forward, 5 steps right, same way in CNC. Tool moves based on the zero. All dimensions are just distances from zero. So instead of memorizing, just think like this. From where I am starting, that is my zero. If this is clear in your mind, half of the CNC becomes easy. Okay, so now we know what zero is, but just knowing zero is not enough. Every dimension in the drawing is given from some reference. Most of the time, that reference is zero. So instead of seeing random numbers, start thinking like this. From zero, how far is this feature? That's so suddenly drawing becomes logical, not confusing. Now, let's bring this to VMC thinking. In VMC, we mostly deals with X and Y for position. X means left right, Y means front back. Now imagine your zero is fixed at one corner. From that corner, if you move right, X increases. If you move forward, Y increases. So when you see a dimension like X50, Y30, just imagine from 0, in X axis it has to move 50 and Y axis it has to move 30. That is your position. Simple. It's as simple as that. Now, let's take a very common example. Hold position. In VMC drawings, holes are usually located using X and Y dimension. That means the center of the hole is given from 0. So when you see a hole, don't just see the circle. Ask yourself, where is the center? And that center will be given as a distance from 0. Once you understand that, you can easily imagine where the hole is on the path. No confusion on that. Now, common confusions. This is where many people make mistakes. They read the dimension but in the wrong reference. For example, dimension is given from the center, but they assume it from the edge. Or arrow is point somewhere, but there it is somewhere else. It's a small mistakes, but will have a very big impact. So always follow the arrows carefully. See exactly from where the dimension is taken and to where it is going. Don't assume, observe and take action. Now, let me give you one simple rule. Yes, never guess your dimensions. Always follow what drawing tells. Look at the arrows, look at the reference points, and then understand the value. If you follow this one habit, most of your mistakes will disappear. Because in drawing, clarity is everything. And clarity comes from careful observation, not speed. Till now, we spoke about x and y, which tells us position on the surface. Now we add a third direction, z. So z is depth. It tells us how deep the tool goes in the material. So imagine this. You know exactly where the hole is in x and y, but you know how deep to drill. Then the job is incomplete. So z is also the most important thing in BMC. Surface is usually taken as Z0. Either the Z0 can be on top of the material or bottom of the material. If the 0 is taken on the top of the material, the cutting happens in a negative direction, like 10 mm, minus 9, minus 8, minus 5. And if it is the Z is set to the bottom, the Z is set to the bottom, the cutting will be for some 10 mm thickness will then 10, 9, 8, 7. It will be in the positives. So if you see Z minus 10, that means that we are telling the tool to go 10 mm inside the material. Simple idea, but very important. Now, how do we find the depth in the drawing? How do we find the depth? Depth is usually mentioned near the feature, sometimes directly near the hole, sometimes as a note. So whenever you see a hole or pocket, don't stop at x and y, always ask what is the depth. Because missing depth means incomplete understanding. And in machining, incomplete understanding always leads to mistakes. So let's connect everything we learned. We have to learn a lot about this more. Actually, this is just what we can tell. It's just a tip of the iceberg. There are lots and lots, but we don't have much time. So now, what have we learned? Let's connect it. So first, what we do? We find the unit, then we find the projection. What projection is used? Then we understand the shape. We identify the zero. We read the x and y positions. Then check the set depth. Then identify features like holes, pockets, slots. That's all. This is the full method. If you follow this step by step, any drawing will become simple and there will be no confusion. Let me tell you what separates an average person from a good CNC operator. It is not speed, it is clarity. A good operator does not rush. He reads the drawing slowly, carefully. He visualizes the part, and only when he starts machining, that is why his work is accurate. So never try to be fast, try to be clear. Drawing reading, actually, it has to be explained. We'll be explaining in detail in our classes. We have our own classes, CNC programming classes, and in these classes, we'll be explaining in detail. That takes some time to explain each and everything. These are just the basic things which I have joined here. Now, what we saw today is just the beginning. We made drawing understanding simple, but to truly master this, you need practice. You need real drawings. Just a small YouTube webinar won't make you perfect. You need the real drawings, real parts, real machine experience. For that is what exactly this education does in our training. We don't just teach theory; we make you understand step by step until you become a confident CNC programmer. So, if you're serious about learning CNC programming, you can connect with us after the session. Let's all move from confusion to confidence. If you have any doubt, please put in the chat and I will try to explain. That's all for today. I think we will just stop here for the day. See you with a new topic in the next Saturday. Thank you so much for being